This section really gets into the big difference between what you've done in your algebra classes in the past and this course. This is mathematics in business, economics. Um, so we've got to look at how what we've already reviewed is applied in those methods. So if you look at all the topics that we're going through in this lesson, it's quite a long lesson. We're going to be talking about cost and revenue and how that finds profit. We're going to be writing equations for cost, revenue, and profit. We're going to talk about break-even points, when a company breaks even with their profit. And we're going to talk about market equilibrium. So, first step is to talk about cost and revenue. So the profit a firm makes on its product is the difference between the amount it receives from sales and costs. That could be overhead, it could be salaries, it could be buying the material to make the products, all of those. That's what we get for profit. Now, in general, revenue is found by taking the price per item times the number of items sold. The cost usually depends on two parts: your fixed costs like rent, utilities, depreciation of your machinery, and then your variable costs, electricity, that type of thing. So to find our costs, we take our variable costs plus what's fixed. So suppose a firm manufactures MP3 players. I know we don't really do those anymore. We're going to go with it. And sells them for $50 each. So revenue is really easy. I'm serious. Revenue is the easy one. Revenue, it's $50 each, so that's 50x. Easy. The costs incurred in the production and sale are $200,000 plus $10 for each player produced. So our cost is going to be $200,000 as the fixed plus $10 for each unit. So what would be our revenue then? Our profit. Profit would be that revenue minus the cost. And I'm not sure where that sound is coming from in the background. So I'm going to provided processing. Yay. Okay. So revenue is 50x minus the cost. So I'm going to have, when I distribute that, that's going to be a negative 10. So that's going to be a 40x minus 200,000. So I want you to think about a few things here. If we have no income, I know we don't make anything, like don't sell anything, nothing sold, zero sold. You're going to lose that $200,000 fixed cost. Now, in example 1, both the total revenue and total cost were linear. So we ended up with a linear function for profit. The slope of the profit function is the rate of change in profit based on the number of units sold. It's called the marginal profit. So the marginal profit on that example is $40 because it was 40 for a slope in our linear function. Suppose that the cost, the marginal cost would have been $10 because that was the slope of the cost function. Marginal revenue is 50. Suppose that the cost for a product is labeled with this function. What is the marginal cost for this product? Well, marginal cost is the slope, and that's going to be $21.75. But what does that mean? It means each additional product costs $21.75 more. Or you can say the cost to produce the products is $21.75 each. That would also work. All right, break-even analysis. We can solve the equations for total revenue and total cost simultaneously to find the point where cost and revenue are equal. On the graph of these functions, we use x to usually represent the quantity produced, and y is our total dollars. The point where the total revenue line crosses the cost line, that's our break even. That's when what we bring in matches what we're spending. So let's say a manufacturer sells a product for $10 per unit. That's my revenue. The manufacturer's variable costs are $2.50 per unit. And the cost of 100 units is $14.50. So let's think about how we could do that one. That's a little differently. So that's giving me a slope and a point. So that one would really be that the cost, so I'm using that point slope formula. The point slope minus, what is that? Minus 100. I know I have a math degree, but sometimes I'm silly about stuff like this. Add that over. Now I have my cost function is 250x. When I add that over, I'm going to get 1200. To find the break-even point, we want to know when the revenue equals the cost. That's the break-even point. My profit's going to be 0. So I can literally set it up to set revenue equal to cost. Now I could do this graphically, but since in the last section we reviewed how to do this all by hand, it's always good to know how to do it by hand. So our break even is at 160 units. So what happens if he sells less than that? And he's going to have a loss. What happens if he sells more units? He's going to make a profit. Do you see why that would be a good point to know about? Now let's talk about supply and demand. Economists and managers always use points of intersection to determine what's called cut out somewhere in the supply, demand, and market equilibrium. Okay, so demand by consumers is related to the price. The law of demand says that the quantity demanded will increase as the price decreases, and the quantity demanded will decrease as the price increases. So in other words, when something costs more than you're willing to pay, you tend to not buy it. But if the price is lower than you expected to pay, you tend to buy. Now, the law of supply states that the quantity will increase as the price increases. So, note that on both of these equations, we use P equals for both of them. And P is the price. And Q is going to be our quantity. So P is for price, Q for quantity. And notice that the supply will keep going up as we increase the price, the quantity. The price goes up. But the demand for the product will go down. So if the supply and demand curves for a commodity are graphed on the same coordinate grid, market equilibrium occurs when they cross. So in this figure up here, they're meeting at 150 on the x-axis and 20. That means the price would be 20. Consumers are willing to purchase 150 units. So if we want to find the point of equilibrium, or the market equilibrium points, we just need to know when those two, the supply and demand, are equal. And it's like the perfect storm. So we would take the demand and set it equal to the supply. So negative 3Q plus 36 equals 4Q plus 1. Negative 7Q equals, that would be a negative 35. Q equals 5. So what would that mean the price is? Well, I need to plug it back in. So I'm going to plug it back into the lower one. 4 times, that's easy, that's 21. So this means if the price is $21, consumers will purchase how many units? Quantity, 5 units. A group of wholesalers will buy 50 dryers per month if the price is $200 and 30 per month if the price is $300. So will buy, that's talking about demand. Will supply, that's talking about supply. So we've got these basically 2 points that they're giving us, 50 dryers for $200. And remember, we're doing our Y as our price. So we'd have the change in price over the change in quantity. So for demand, I've got 2 points. I've got 50 gives me 200 and 30 gives me 300. So I would need to find the slope between those 2 points. And now I need an equation for demand. So I can use either point, and I'm going to use point slope. So the price minus 200 equals the slope times the quantity minus 50. Notice how everything comes together from what we've already learned. Now I need to find my supply function. Same thing. We have 20 for 210 and 30 for 230. So we will find the slope. Then we need to find the equation. I add that over, that's going to be 170. So I now have my two equations. I have my equation for supply and demand. Find the equilibrium point. So I want to know when those two are going to be equal. So when does the supply equal the demand? I'm going to just go ahead and take 450 minus 170. It's 280. Divide by 7. Let's use this one. So I end up with price of $250. Consumers will buy 40 units. Taxation. That throws a little kink in the formula when we're talking about supply and demand. So suppose a supplier is being taxed so much per unit sold, and they kind of want to pass that on to the consumer, so it's in the selling price, and so that they're not having more cost. So if the original supply function is F, then when we add on the tax, we're just going to add that onto the supply function. So notice what that's going to do to the equilibrium. So here's our supply function before tax. But when we add the tax to it, it's just going to move it up. But it's also going to change our equilibrium point. So let's look at an example of that. So from example 5, wherever that was, oh, that's on the other side of here. Oh, Lordy. Okay, so in example 5, we ended up with the supply function was $2Q plus 170, and the demand function was negative 5Q plus 450. And the equilibrium point was, I had to flip my page over, 40, 250. What if the wholesaler is getting taxed $14 per unit? So that changes my supply function. That means my new supply function, I'm going to tack on that $14 at the end. So it's going to be P equals 2Q plus 184. That's going to change my equilibrium point. Let's see how much it's going to change it. Okay, so 450 minus 184 gives me 266 divided by 7. I get Q is 38. So I'm just going to plug it back into my supply function. And get that the price is 260. So notice it does decrease the quantity a little bit. and increases the price a little bit. But notice it doesn't increase the price all the way up $14 from the last equilibrium point. So my new equilibrium is 38 units at $260 each. And that's the prime spot to be in. That's when your supply and demand are equal.